Paper 1, Specimen Set 2. Give the meaning of the term bronzed-Lowry acid. It's an H+ donor. It donates protons or H pluses. What's meant by strong acid? Completely dissociates in water to make H+ ions. What have I been given? I've been given concentration of hydrogen ions. So no, I haven't. I've been given the number of moles of hydrogen ions. I've been given the volume, so I can work out concentration. Concentration is moles divided by volume. Remember, to get the volume 25 centimetre cubed into decimetre cubed, work out the concentration 0.058. Moles divided by 0.025 is 0.058. pH is minus log to the base 10 of H plus concentration 1.24. Calculate the pH of a solution formed after the addition of 35 centimetre cubed sodium hydroxide to original 25 centimetre cubed of monoprotic acid. Monoprotic acid is something like HCl, where it makes 1 mole of the acid makes 1 mole of H+. Unlike diprotic acid, like sulfuric acid, where 1 mole of the acid makes 2 moles of H+, it dissociates. Volume of sodium hydroxide, I've got concentration, so clearly it wants me to work out from those two values the number of moles, so concentration moles divided by volume, moles of sodium hydroxide 0.0525. Moles of acid from the previous question is 0.00145. If they had acid and base together, sodium hydroxide being a base, then they can neutralise each other. I need to work out which is in excess. Sodium hydroxide is the larger number, so the amount in excess, take the two numbers away, 0.0038 moles of sodium hydroxide in excess. So I need to work out the concentration of sodium hydroxide. How do I know that? It's because I've been given the ionic product of water, and the ionic product of water is H+ concentration multiplied by OH minus concentration. So if I can find out the OH minus concentration, I can use Kw to work out H+, and I can use that to work out pH. So Kw converts H+ into OH minus and vice versa. So I've got the number of moles of sodium hydroxide in excess, 0.0038. I now know the total volume after I've added 35 and 25 centimetre cubed of reactants together. 60 centimetre cubed or 0.06 decimetre cubed. Moles 0.038 divided by 0.06 decimetre cubed, 0.0633. So that's the concentration of sodium hydroxide. As I said before, Kw allows me to convert sodium hydroxide concentration and hydroxide concentration to H+ concentration or vice versa. So I can plug in the concentration of OH minus concentration, work out the H+ concentration 1.58 times 10 to the minus 13, minus log to the base 10 of it, 12.8. That seems reasonable if sodium hydroxide, a base, is in excess. It's going to be a large value, somewhere in the region of 11, 12, 13, something like that. A buffer solution is made when 1.5 grams of sodium hydroxide are added to 1 decimetre cubed of 0.15 mole per decimetre cubed of a weak acid. So the first thing you've got to do is work out the number of moles of acid. How do I know that? Because I've been given a volume and a concentration. So concentration is moles divided by volume. 0.15 is the concentration. Number of moles divided by, I've got 1 decimetre cubed, easy. 0.15 times 1 is 0.15. So number of moles of a weak acid that I've got is 0.15. Now, I've been given a mass of sodium hydroxide. I know it's MR. I can work it out to be 40. It should be there. Instead of 39, it should say 40. 23 add 16, add 1 for the H is 40 rather than 39. 1.5 divided by 40 is around about 0.0375. So now I've got the number of moles of sodium hydroxide. I need to work out which one's in excess because I'm adding the two together, just like in the previous question. The acid is in excess, so 0.15, take away 0.0375, 0.1125 moles of acid is in excess. I know what an acid does. It's given me a fictitious acid, HA, so it's going to break up into H plus A minus. All acids break up into dissociate in water to make H pluses. The weak acid is not going to fully dissociate, unlike a strong acid, but it's still going to make H plus and A minus. So I've written an expression for Ka, H plus multiplied by OH minus concentration divided by HA. For buffers, you can't use H plus squared. because you've added extra A minus to it. You've added some of the salt to it. So you can't use H plus squared. But what you can do is you can cancel the concentration top and bottom and convert concentrations into moles. So Ka equals H plus concentration moles of A minus divided by moles of HA. That's usually a first step in a buffer question. So how do I resolve that? Well, the moles of HA is the moles of acid that's left over, which was 0.1125. So I'm very nearly there now. I've got my Ka 0.000179 equals H plus concentration. The only thing I'm missing is my moles of A minus. Now the moles of A minus equals the moles of sodium hydroxide, which was 0.038 at the start. So let's just have a look at that expression again. Ka, I've got 0.000179 equals H plus. Moles of sodium hydroxide is on the top. That always equals the number of moles of A minus divided by the moles of HA that's left over in excess, which was 0.1125. I can work out H plus concentration, I can work out pH 4.27. Question 9. The graph was obtained from the experiment in which acid was reacted with alkali. It looks as if you're starting with the acid and you're adding some, you're starting with the alkali and adding some acid because the pH is going down. It's starting at around about pH 11, so that's not particularly high. A strong alkali, strong base would be up in 12, 13, 14, so I've got a weak base, but it's coming right down to pH 1, which means I've got a strong acid. An example of a strong acid is hydrochloric acid, and an example of a weak base is something like ammonia, NH3. Suggest how you do that. Well, you'd start off with some alkali in the beaker or some base in the beaker, the ammonia in the beaker, and then you'd add small amounts from a burette, small amount at a time of the acid, stir and use a pH meter to record the pH after you've added each portion of the acid. Student was provided with samples of 3 different indicators. How it could be refined to find the most suitable indicator. Well, you just repeat with each indicator and select the indicator that changes colour rapidly when the pH changes from about 7 to 4. So I'm looking at the graph again. pH 7 is where it's starting to drop down. The pH is changing rapidly from pH 7 down to about pH 4. It's curving above pH 7. It's curving off again below pH 4. So I'm looking for an indicator that changes between pH 7 and pH 4. And you just repeat the experiment now with an indicator and look for an indicator that changes between those 2 pH values.